Kepler's laws of planetary motion consist of the following three laws proposed by Johannes Kepler after studying his boss, Tycho Brahe's data. These laws describe how planets move in a sun-centered system. They have many applications, some of which involve predicting the orbits of satellites around the Earth, predicting the orbits of moons around other planets, and they even helped Newton develop his theory of universal gravitation. But what are these three laws of planetary motion? The first law of planetary motion is the fairly simple law of ellipses. It states that the orbit of a planet is an ellipse with the sun at one of the foci of said ellipse. That's easy enough. This particular law challenged the long-held belief that planets move in perfect circles. The second law is the law of equal areas. It states that a line drawn from the planet to the sun covers the same amount of area in the same amount of time. Suppose a planet's orbit is like an ellipse-shaped pie. The pie slice that the planet makes in 1 month on the side further from the sun, and the pie slice it makes in 1 month on the side closer to the sun, are the exact same area, and this works for any time unit, including hours, days, or even weeks. The third law is a law of harmonies, and in my opinion, it is the most interesting of the laws. Unlike the first two laws, the law of harmonies deals with multiple planets orbiting the same sun. It states that the ratio between the square of the orbital period, which is how long the planet takes to circle the sun, and the cube of the average distance to the sun is the same for every planet in the system. For example, Mars has an orbital period of 1.88 Earth years, and the distance to the sun is 1.52 astronomical units. Thus, the ratio of the square of the orbital period and the cube of the average distance to the sun for Mars is 1.01. For Earth, the orbital period is 1, and it is 1 astronomical unit away from the sun. Thus, the ratio is just 1. As you can see from this chart, this law holds true for every planet in our solar system. All the ratios for every planet are nearly the same, including Pluto, our dear ex-planet. Kepler died before he could explain why his third law worked. Fortunately for him, a young physicist named Isaac Newton derived his theory of universal gravitation from Kepler's third law and simultaneously explained why it worked. Kepler's laws about planetary motion made sense of Tycho Brahe's data, and they had a huge impact, from destroying long-held notions about the universe to being used centuries later in many fields today. I hope that I helped you get a better understanding of Kepler's laws of planetary motion that govern the movements of the planet you call home and of many other objects and their movements in the universe.